We are discussing a very important topic of NLP, namely named entity recognition. And we mentioned that named entity recognition is a little difficult to place in the NLP stack. Some school of thought says it should be done after part of speech tagging has been completed, which means nouns have been identified, and now out of the noun, find out the named entities. Now, one point that may arise is that in pause tagging, NNP is already the tag for proper noun. So why any special care for named entity then? Now, the problem is that English has capital letters to signal a proper noun, but it can also be confused because common nouns in the beginning of a sentence can start with capital letter. So that disambiguation needs to be done. And part of speech tagging is supposed to do this disambiguation. But languages which have no capitalization or capitalization for all nouns, as in German, the problems are more complex. And you can also have named entities which are composed of smaller named entities. So I gave the example for Indira Gandhi Open University, or Tale of Two Cities, which is the name of a book. So these are multi-word named entities, and detecting them is complex. So there is some theory that named entity recognition falls between chunking and pause tagging. Chunking is shallow parsing, and pause tagging is below that. So named entity recognition can fall here. But named entity recognition also has a lot of relevance for semantic role leveling, identifying who is the agent, who is the object, instrument, and so on. So named entities carry a lot of semantics with them. And then the multilingual named entity recognition is a complex task, most importantly for reason of efficiency. If we have identified a named entity for Hindi, we should not spend the same kind of effort for Marathi, because named entities do not change from language to language typically. Now, though named entities are ambiguous, there often is a signal in the sentence to identify if the noun is a common noun or proper noun. So Apple increased its laptop production. Here, laptop is a strong signal to say that here Apple is not fruit apple, but Apple organization. And Apple a day keeps the doctor away, no capitalization, and an article before Apple is a signal for disambiguation. But we must account for the fact that writing can be sloppy, and it can be in an informal setting like WhatsApp messages, where one is not very careful about capitalization and so on. So for informal text, the problem can become complex. Now, multilingual named entity, the main motto there is extract once and use many times. We discussed last time that named entity recognition is a machine learning task, or it can be a rule-based task also. In machine learning-based methods, supervised methods which make use of graphical models, deep learning, unsupervised methods, they are based on corpora, and they can also do rule induction. Like there is a system called Know-It-All, which produces rules for named entity recognition. In unsupervised methods, we essentially cluster the names. So all the names of cities would be together, names of organizations would be together, Apple, Microsoft, Amazon, Google together, names of cities together. And then in semi-supervised methods, we enter the label, refine cycle, label, refine, label cycle, where some amount of corpus is already labeled, and that is used to train a machine. Then the model labels more data, of course, with inaccuracies, which is corrected manually. Then that is added to the training data. The model is rebuilt, and that model classifies little more data and so on. And hybrid methods actually combine rule-based, statistical, deep learning-based methods, a pair of them or three of them. Now, named entity recognition is very crucial for two tasks, quite a few tasks. The most immediate task is information extraction. In information extraction, we are interested in identifying the entities. Mumbai is a big city. Mumbai has to be identified. Delhi is the capital of India. Delhi and India are entities. Capital of is a relation which links Delhi with India. And Mumbai and city are also linked by means of co-reference relation. So when we link two entities with a relation, that relation is also called the attribute. Modi, Prime Minister of India. So PM of is the property of that relation. Named entity identification and named entity recognition are two different problems. You are doing named entity identification in your assignment. Named entity recognition is little more involved. So just like unlabeled dependency and labeled dependency, there is a difference of complexity between the two tasks. In unlabeled dependency, we want to find out the pair of words which are linked by a dependency relation. We don't know what that relation is, but is there a relation between a pair of words? The answer is yes or no. If it is yes, we have to link. And there we also have to find out which is the head, which is the modifier. The arrow will go from the head to the modifier. So in named entity recognition, we have types and subtypes of named entities. So a very important task, and which has remained relevant always, even now, where we have to create structured information from unstructured data, that is from running text, identify structured information. So here we have a running text. Microsoft Corporation CEO Bill Gates railed against economic philosophy of open source software. Railed against means criticized heavily. So this is running text, and when we begin to fill the entities and relations, Bill Gates is the name, Bill Vecte is another name, Richard Stallman is the third name, and the organizations are Microsoft Free Software. Title or relation is CEO, Bill Gates, CEO of Microsoft. Bill Vecte, VP of Microsoft. Richard Stallman, founder of Freesoft. So CEO, VP, founder, these are relations. Of course, one can club all of them together and say some kind of head of. So Bill Gates, head of Microsoft, Bill Vecte, head of Microsoft, Richard Stallman, head of free software. So filling out this kind of table is an example of of converting unstructured data to structured data. And each row, which is entity one, relation entity two, is called a tuple. It is also called a knowledge tuple or knowledge nugget. They play a very important role in NLP, including today's deep learning and LM-based systems. The power of language models can be augmented very heavily if we encode these entity one, relation entity two, these tuples, in the form of embeddings and add them to the deep learning system. So they have been shown to be very effective for controlling hallucination. This is their attraction. So NERC is the named entity recognition and classification, which involves identification of proper names in text and classification into a set of predefined categories like person names, organization name, location name, and miscellaneous names. Miscellaneous can contain things like date, time, number, percentage, monetary expression, and so on. Now, NEI and NER are two different tasks, as we have discussed already. Now, what are the challenges in NEI and NER? Okay, what is it that is difficult? So first is that there can be many-to-many relationships. So one named entity can denote multiple entities outside, or one entity can have different names. So, for example, Prof. Manning. Prof. Manning is a professor of NLP in Stanford University. Name is Professor Christopher Manning. So he can be referred to as Prof. Manning, Chris Manning, Dr. Chris Manning. Three variations. There can be ambiguity. Washington can mean a location or a person. May can be the name of a month or a person. Peter May was selected for Australian team in the month of May. Ford can be the name of a person or an organization. 1945 can be date or time. 1945 can also mean 7:45 a.m. or p.m. Of course, we may say that, oh, in that case, you need a dot between 19 and 45. But the writing can be informal, loose, sloppy, in which case this can be dropped. Ambiguity is common words like kavita in Indian languages can be the name of a person or can mean a poem. So ambiguity, like any other problem of NLP, poses a challenge for named entity recognition. And obviously, all kinds of, for any kind of disambiguation task, we have to make use of either rules for disambiguation, or we have to make use of annotated data and probability to get the maximum probability option after disambiguation. There can be more complex problems of NER. For example, there can be issue of style, structure, domain, genre, all of which contribute to ambiguity. So in the domain of politics, Washington most likely means George Washington, the president. And for tourism domain, Washington is very likely to mean the place Washington, DC. Structure, style, genre, all these can contribute to ambiguity and also can supply information for disambiguation. So structure, the PP attachment, clause, all these things can indicate whether what type of named entity the entity is. Punctuation plays a role, spelling, spacing, formatting, all of them have an impact. So Department of Computing and Maths. Here, DEPT, after that you have a full stop or a dot. Manchester Metropolitan University, Manchester, United Kingdom. So this whole thing is the address at Department of Computing and Maths, Manchester Metropolitan University, Manchester, United Kingdom. So here there is a large number of named entities, but the whole text is one single named entity, namely it is an address, which is composed of many named entities. The many-to-many relationship between named entity and what it refers to is shown by this table. So E353 is the row ID. It refers to Manning, Professor Manning, Christopher Manning. E201 is oxygen, O2. E356 is Kolkata, Calcutta, West Bengal capital. E404 is IIT, Indian Institute of Technology, Indian Institute of Tech. So each row is an example of a reference to multiple names mapping. This is an example of this whole table is an example of many-to-many mapping, because under one column also you can have multiple IDs. Okay, here it is not shown, but under one column you can have multiple IDs, and for the row of one ID you will surely have multiple names. Now, an indication is how much accuracy can you really achieve in named entity recognition? How to go about answering that question? What will be the skyline NER performance? I mean, of course, we would all like it to be 100% correct uh, with full precision, full recall, no omission, no commission. But 100% doesn't happen, even for human beings. So for human beings' performance provides a skyline for the task, like other NLP tasks. So this is captured by what is called inter-annotator agreement. Inter-annotator agreement is an indication of what is the probability that two different annotators will agree on a label. So for example, I take the two words cricket bat, and I ask two annotators to annotate this phrase, cricket bat. Most likely, both the annotators will agree that bat is a noun. Cricket bat, bat is a noun. Cricket, they may disagree. One may say, well, it is a noun functioning like an adjective. Another would say, no, it's noun, and let it be noun. Higher level NLP task will find out that this is acting like an adjective. So they may give two different levels, adjective and noun. Now, inter-annotator agreement is a measure which observes how many times two annotators have agreed with respect to the level and how many times they have disagreed. So based on this number is computed, and IAA, that gives an indication of the skyline performance. If the inter-annotator agreement is 85%, then the machine's performance will be in the vicinity of 80%. This has been seen for words and disambiguation. Now, applications of named entity recognition are numerous and all very important applications. Intelligent document access, where a piece of software, an automatic system, has to make sense of a document. It has to access a document, access the information content of a document. For example, in news articles, scientific articles, for example, there is this Medline abstract where many names of medicines, diseases, body organs, their scientific names appear in the Medline corpus. So from there, we have to identify those names and then understand the article. Okay. So paracetamol is used for controlling fever. We have to understand this sentence here. First step will be to understand paracetamol. Then information and retrieval and extraction. If we augment the query with named entity, then the information retrieval, that is the page retrieval, as well as obtaining correct information from the page, they become more effective. So for example, we are asking a query with Washington, and we give Washington's named entity also, Washington place, that is the query. Then all the pages which correspond to Washington, DC, and not George Washington, will be retrieved. Similar is the case for information extraction. In machine translation, a very important problem is whether to translate or to transliterate. So Indira Gandhi Open University, which is the name of a university, it is translated into Hindi as Indira Gandhi Mukta Vishwavidyalaya. Now, Open University has been translated, Mukta Vishwavidyalaya. Indira Gandhi has been transliterated. In automatic summarization, paragraphs containing more named entities are most likely to be included into the summary. So typically the sentences which contain the named entity, they cannot be typically dropped in the summary. So suppose there is an article on Delhi, and if the word Delhi appears in a sentence, and maybe after that it is referred to by a pronoun, the sentence where Delhi appears as a name and not as a pronoun, it is very likely that that sentence will be included in the summary, because most probably Delhi is being introduced the first time there. Delhi is the capital of India. It is a very popular city. It transacts a lot of financial businesses and so on. So sentences containing named entities are very likely to be included in the summary. That's an important language property which needs to be kept in mind. In question answering system, named entities are important to retrieve the answer. Who is the Prime Minister of India? Which country is Modi PM of? These target named entities. And also for accurate answering of the question, disambiguating disambiguating the named entity is important. So if I say, did you visit Washington anytime? Now, I most probably mean Washington, D.C. And the answer could be yes, last summer. Now, if the system thinks that this Washington is President Washington, then it might come back and answer Washington existed in 1700 something, and you were not born at the time. How I was not born at the time, so how could I visit Washington? So those kind of misled answers can be produced if we don't detect the named entities type correctly. Speech-related task named entity is important for identifying the number format, telephone number, date format. In speech rhythm, typically we give a short break after the name of the person, and we try to articulate the names more carefully and clearly so that the rest of the discourse is more smooth. And solving out of vocabulary words is important in speech recognition. Named entities sometimes do not appear in the training data at all because the deployed system is functioning in a new use case environment. Now, named entity recognition requires corpora and annotation to be able to use machine learning techniques. So there are some famous corpora. For your assignment, you are using probably the most famous corpus, which is CONLL, Computational Natural Language Learning. So this first URL, CONLL 2003 NER, here named entities are in English and German. Then the other one is containing named entities in Spanish and Dutch. ACE is a very important resource. It has names as well as relations. So it is a entity extraction corpus. Tide's surprise language exercise, their named entities were in Hindi. NER SIL shared task named entities are in Bengali, Hindi, Telugu, Odia, and Urdu. I mean, these are of interest to Indian audience. Now, the Indian research groups also have contributed named entity corpus, especially the FIRE corpus, FIRE, Forum for IR in Indian languages, which is running for several years now. It's a shared task. And there we do find named entity tagged corpus for Indian languages. And biomedical and biochemical corpora, BioNLP 04 shared task, BioCreative shared task, AIMed, these are all from medical domain. Medical domain is very, very eager to have high quality named entity recognizer because there are many biological names, medical names, which appear in the medical corpora. Let us discuss the tag set. The text is tagged, and you'll remember the discussion for post tag text, post tagging resources, post tags, and dependency relations. You would recall nsubs, dobj, which are dependency relations. Here also for named entities, there has been a careful effort on categorizing names and types and subtypes. So names of persons, organizations, location, expression of times, quantities, monetary values, percentages, they are very important to be identified in text. So here is an example. Jim bought 300 shares of ABC Corporation in 2006. Jim bought 300 shares of ABC Corporation in 2006. So this is how the tagging is done. It's like looking like XML. So now let us read this carefully. First tag I find is for gym, where you have the start of the tag, NMX type person, gym, then end of tag slash NMX angular bracket. So it says that gym is a named entity. Type is NMX. Okay, it is not a number or date or time. It is of NMX. NMX means all those tags which correspond to place, person, location, organization, and so on. So I believe NMX stands for entity marking. So gym is of type NMX and subtype person. 300 is of type quantity, and then shares of, there is no tag for this. ABC Corp is of type NMX and subtype organization. Day 2006 is of type timex. It is a time expression, and subtype is date. So this is how the full corpus is tagged. As you can see, this is quite painstaking if you do manually. But typically for named entity data creation, there are interfaces, and these interfaces help you. All you have to do is select the named entity, and then there is a pop-down menu, and you select the type NMX, and then once you click on NMX, another pop-down menu comes up with subtypes, and there you select person, then automatically the text will get tagged. Similarly for 300, ABC Corp, and 2006. So notice that 2006 is not of type NewMex, unlike 300. It is of type timex because it is a year. So this is a disambiguation task. So there is a hierarchy for named entity types as is shown here. Any types are primarily three: NMX, NewMex, timex. So let us remember this because this is important for NLP. Under NMX, we have a large number of subtypes: person, location, organization, organisms. Organisms could be bacteria, for example, the name of some bacteria. Cuisines, dosa, for example. Entertainment, name of some movie. Disease, name of some disease. Names of plants. Names of facilities, Mahatma Gandhi Road, okay, or Vivekananda Vyamshala. Locomotives, names of vehicles, trains, planes, artifacts, the name of some instrument, for example, let's say oscilloscope, Siemens oscilloscope. So these are the categories under NMX. It captures most of the important names associated with life's processes. NewMex, the number. A number can be of type subtype distance, quantity, money, and count. Okay, 300 flowers. INR 500, quantity 50 kgs, distance 20 miles, and so on. This is NewMex. And timex also has many subtypes, all of great importance and day-to-day occurrence. Timex may have time, 7 p.m., the day, Wednesday, month, July, period from 7-10, that is 7 to 10 p.m. maybe. Date, 20th November 2023, year, just the year, some special day, Independence Day, and so on, 15th August, for example, for India. So these are the subtypes under timex. So all these are from the MUC dataset, MUC, and I strongly encourage you to visit MUC site, where all these tags have been explained carefully, just like you did for universal dependency tags. And now universal dependency relations. So by way of elaboration of one or two categories, person. Person can be individual, then group. Under individual, you can have family name and title. So persons are entities limited to humans. A person may be a single individual or a group. Okay. Individuals refer to names of each individual person, also includes names of fictional characters found in stories, novels, etc. Individual names can occur with family name and often referred to the title. For example, Mr. Jones, Dr. Chakraborty, etc. with their name. Group refers to a set of individuals. Here are some examples. Mr. Chandrababu Naidu is the president of Telugu Desam Party. Chandrababu, person, individual. Naidu, person, family name. Mr. person, title. So this structure is capturing the whole named entity, Mr. Chandrababu Naidu. Apollo Hospital Doctors is an example of person group. So annotation, as we have seen, the shuttle with an international crew of 6 was set to blast off from Kennedy Space Center on Thursday, 4:18 a.m. That is the full sentence. But this raw sentence has been now enriched with the tags. The shuttle, nothing, with an international crew of nothing. Then 6. 6 is of type numex, number. Type is number. It is not distance. Was set to blast off, no named entity so far, from, now a named entity, Kennedy Space Center, which is of type organization / location. It is of type NMX. And then we have a timex, Thursday, which is Thursday 4:18 a.m. So it's a complex timex. There we have date as Thursday and time as 4:18 a.m. So timex can contain another timex. EST. So this is an example of having NMX, NUMX, timex, everything, all the big categories. Okay, so those were data sets, annotation procedure, hierarchy of tags, then named entity recognitions, challenges, named entity as a concept, and so on. Now let's look at some of the computational approaches to solving this problem. Whether am I still audible and slides are visible? Somebody verify. Am I audible, visible? Slides are visible?
Yes, sir. Yes, sir.
Let's go to computation. So named entity solution approaches can be handcrafted systems, which are rule-based. They latch onto patterns, and they also make use of what is called gazetteer. This is a very important concept for named entity recognition. Gazetteers are a list of named entities. So typically, gazetteers can be constructed from, for example, the electorate list. People's names are there in the election voter list. We call this voter list. So from there, the names of persons can be gathered. Then gazetteers can also mention the jillas, talukas, rajdhanis, name of the state, and so on. They can also mention the organizations, Accountant General Office, State Bank of India, General Insurance Agency, and so on. So gazetteers are a very valuable resource for entities. And typically, you can pick up 2 entities from the gazetteer list and think of a relation that links them. State Bank of India in Calcutta, for example. Automatic systems are based on machine learning. They're supervised, semi-supervised, or unsupervised. Today's systems are all deep learning based, and there are also hybrid systems. Now, large language models are doing extremely well for named entity recognition because of their very long context. I mean, if I see Washington and there are, let's say, 4,000 words behind it, which is used for computing the conditional probability, there is hardly any chance that I'll go wrong. So large language models are extremely effective and powerful in detecting the named entities along with their types. And if you prompt the ChatGPT or Mistral, whichever large language model, just give a prompt that you have to identify the names for me. Here is an example for you. London is the name of a city. And then you can also make the prompt more complex. I give you a sentence and I tell you which are the named entities here. For the next sentence, you have to do the same for me. And they are very good. And they're very good because of the very long context which they exploit to compute the probability of the class. And there is almost zero possibility that the probability, the computed probability will be wrong. It will be designating a non-named entity as named entity and so on. But for languages which have no LLMs, not even enough corpora for neural network-based systems, for them handcrafted systems support vector machines. They are very useful. They're the only way to go. So you've already mentioned Mark 6, Mark 7 corpora, CONLL corpus, A's, DIDES, and so on. Okay. Performance metric, that's there's no surprise there. We have to make use of precision and recall and F measure. Now, pre-processing is needed many times for NER. We have to detect the format. We have to do word segmentation like Chinese. We have to do tokenization, sentence splitting, part-of-speech tagging. These are required for pre-processing. Now, the automatic approaches are based on learning of statistical models, or we learn the symbolic rules from a trained ML model. And machine learning based approaches typically break the named entity task into two parts, recognizing the entity boundary and classifying the entities in the any categories. So Indira Gandhi Open University, we have to first detect where does the named entity begin. Okay, and there we are helped by the BI notation. In Indira Gandhi Open University was established in 1992. So 1992 is one named entity. It is time X. And Indira Gandhi Open University is of type NMX, but it begins from Indira and ends in university. So we first identify the whole length of the named entity and then find out the time. So tokens in the text are coded with IOB system or BIO system. O is outside, B XXX, the first word in the named entity, I XXX, all other words in the named entity. For example, the sentence is Argentina played with Del Bosque. So Argentina is B lock, played is O, with is O, Del is BPER, Bosque is IPER. So Del Bosque is a name of player. He is a person with the beginning part Del and the next part Bosque. The probabilities are computed with the probability of the tag I, that means what is the tag at the ith location, based on the properties of the token I. And there can be external evidences in the form of the neighborhood, token I -1, token I +1. All these are as usual in any kind of sequence classification or sequence labeling problem. Decision trees have been used using training data. And there are some noteworthy papers. Sekine et al. is a very well-cited paper, 1998. Baluja et al., 1999. They achieved an F measure in the region of 90%. Viterbi ID3, C4.5, all these algorithms were used, and they're all decision tree algorithms. Oops, sorry. Okay. Then HMM-based methods have been used. These are generative models. They make use of Markov model Viterbi algorithm, and it works well with large amount of data. There was one well-known system, Identifinder, 1999, and 1997 another system called Nimble. Maximum entropy and conditional random fields have been extremely successful for named entity recognition because they are feature aggregators. They collect the feature of the word which is to be examined for named entity, and the surrounding words and named entity tags, pause tags, and so on. So there are lots of features which are available as signal. We just aggregate them and compute the probability based on them. So there was this system called MENE, M-E-N-E, which makes use of capitalization and other lexical features. It achieved an F measure of 89%. What machine learning features are used? Lexical features like words, the properties of the words, part of speech, orthographic information, what suffixes does it use, affixes, prefix, suffixes, does it appear in the gazetteer? If it appears in the gazetteer, then which part of the gazetteer? Is it in the gazetteer of cities or in the voter list? Okay, all this information are features and they can be aggregated. External unmarked data is useful to derive gazetteers and for extracting training instances. So I mentioned gazetteers and their importance in named entity recognition. Gazetteers come as RAG these days, retrieval augmented generation, in deep learning models. Okay, and RAG deep learning combination is very effective for named entity recognition. Identifinder, BK et al. 1999. It is based on hidden Markov model, very well-known named entity recognizer. And there were 7 regions of HMM, that is one for each mark type, not name, begin sentence, end sentence, and mark type means timex, nmx, numx. Features are capitalization, numerical symbol, punctuation marks, position in the sentence. 14 features in total combining the above information. Contains digit and dash is a feature. Contains digit and comma is a feature for the word. So Identifinder was evaluated using Mark 6 data in English and MET1 data for Spanish. Mixed case English was used. The Identifinder system gave about 95% accuracy. Best rule-based system gave 96% accuracy. Spanish mixed case Identifinder is 90%. Best rule-based is 93%. What is mixed case? Mixed case is where the raw corpus is not normalized. Okay, all capitals are not turned into small letter, which I think you have done in case of a pause tagging assignment. Impact of the size of the data, trained with 650,000 words, but smaller words with half of the data, similar performance with half the data. Less than 100,000 words reduce the performance to below 90% in English. MENE was another system. This is a hybrid system. It combines rule-based with machine learning-based approaches. Tokens are tagged as XXX start, XXX continue, XXX end. So this is essentially BIO. So there were many conventions for multi-word named entities, but ultimately it was BI convention which stayed. It used maximum entropy classifier. And there are many features. Tokens begin with capital letter. Token is a 4-digit number. Dependencies on the surrounding text. In the neighborhood of plus minus 2 words. Mr. for people, to for locations. So if I see to, I will go to Calcutta. So to is a signal for a location. Dictionary features, which is equivalent to gazetteers, first names, company names, date, abbreviations. These meta-level information we can obtain from the gazetteer. External systems, whether the current token is recognized as an NE by a rule-based system. So I mentioned that this MANE system is a hybrid system. It is finally statistical, but it makes use of a primitive rule-based classifier. So Mark 7 was used for training and testing. 84% F measure. Rule-based system is 86 to 91%. MANE plus rule-based system is 92%. Learning curve, 20 dogs, 80, 81 F measure. 40 dogs, 84. 100 dogs, 90, about 90. 425, 92%. So it shows that as we increase the data size, the accuracy also increases. Now, there was an exercise under FIRE, I believe, and also under Machine Translation Consortia, where named entity performance for various Indian languages was noted. This was about 10 years back. And all the systems are based on conditional random field. Anna University, a research group called KBC, they did that exercise. So all research groups gave them data, Tamil, Punjabi, Bengali, Marathi. Marathi data we gave after annotation. And at the time, the F measures, you can see English was 74, Tamil 68, Punjabi 68, Bengali 62, Marathi 64, Telugu 41. So this was pre-LLM era. And this kind of accuracy was obtained. Of course, 60% accuracy for named entities really not good, because information extraction, semantic role leveling, machine translation, everything depends on this. So all of us understood that some other solution has to come for increasing the accuracy. Conditional random field is very good, making use of all features which are exploitable, but still the accuracy was of this form. But those values are no longer valid. With LLMs, they are very high accuracy. And why LLMs? LMs also, like Indic BART, then Indic Voice for speech, then Mural. So all those Indian language models are good in capturing named entities. So the HMM-based system is very similar to part-of-speech tag-based system. We essentially have to compute the maximum probability for PRNC given W, where NC is the named entity class sequence. So Indira Gandhi Open University, the whole thing should be tagged as a named entity, and the type is organization, given the word W. So then we are very familiar with what needs to be done after this. We have to make use of base rule. And then there are details on the schematic for named entity detection. The start of sentence and end of sentence. In between, the named entity recognizer goes on identifying person, organization, and not a name. So these are the classes. Person, only two classes are shown here. And not a name is, of course, the most frequently occurring class. The generation step makes use of the probabilistic formulation, PRNC. Given NC minus 1, that means NC of the previous tokens. W minus 1 means the previous word. And the probability of word and feature combination given the named entity class and the named entity class of the previous tag. So this is a probabilistic formulation which is obtained by making use of Bayes' theorem and then Markov independence assumptions. So here is an example. Mr. Jones eats. This is a sentence. And the named entity tag should produce the following: Mr. Enamex person Jones, Enamex. So Mr. and then Jones is under NMX, and then Eats. I believe Mr. also should be inside NMX because it becomes a multi-word named entity. Okay, so that is a small detail, but see the computation. You will recall how part-of-speech tagging is computed. First of all, you can see there is a lot of product, a lot of multiplication happening. And the multiplication is essentially uh, computing the probabilities of different arcs in a path. And these probabilities are getting multiplied to compute the probability of the whole path, finally giving rise to the winning category: person, organization, location, new x, time x, whatever is the type. So this is essentially the Viterbi-like computation for name entity recognition. Okay, so that was a discussion on named entity, and a course on NLP is not complete without named entity recognition. Let me start the discussion on another very important topic now.
Yes, sir.
Okay, so now we begin another very, very, very important topic, lexical knowledge network. Even though there is LLM and deep learning and so on, everybody realizes the importance of RAG, the agentic LLM, then RAG, retrieval augmented generation, which gets much better results if the outside knowledge or information is in the form of a knowledge network and not in the form of a raw corpus. So we can see lexical knowledge networks. No NLP course is again complete without some knowledge of the lexical knowledge network. So what is lexical knowledge network? Here is the motivation. We of course have ML-based methods proliferating, but deep knowledge-based methods are still needed. Okay. So for example, for named entity recognition, if we know the if we know the named entity type of an entity, and if we indeed know that the entity is a name, then it actually helps in subsequent NLP tasks. And the training can achieve higher accuracy with lower amount of data, provided all these external knowledge is available. Machine learning methods capture surface phenomena and can do limited inference. So machine learning essentially captures correlation or patterns, identifies patterns. And they can therefore do limited inference, which is why they suffer from bias, hallucination, and so on. Deep knowledge is encoded in lexical networks. For text entailment, question answering, and other high-end NLP tasks, we need deeper knowledge. The fact that paracetamol cures fever or paracetamol brings down body temperature, this is there in the raw corpus, but it is also there in lexical knowledge network in a much more refined form without noise, because these are human crafted. So consider the following problems. How do you disambiguate a web in the spider spun a web from go surf the web? How do you summarize a long paragraph? How do you automatically construct language phrase books for tourists? Language phrase books for tourists are common terms for survival. Where is the police station? Where is the medicine shop? Where is the hospital? And so on, which are important for tourists. Can a search query such as a game played with bat and ball be answered as cricket? So those are the tasks, language-based tasks. So let's look at some foundational points. The difference between syntagmatic and paradigmatic relations. This is really a very important notion. There are lexicosemantic relations like synonymy, antonymy, hypernymy, meronymy, troponymy, etc. When we say a cat is an animal, cat and animal are related by the relation is a. So that means cat is a kind of animal. So is kind of or is a relation. And the other relation between two words can be co-occurrence. They occur together in a sentence. So cats and mew, dogs and bark, elephants and trumpet. These are co-occurrence relation because they appear together in a sentence. Word nets capture what is called paradigmatic relation, and concept net, which is another well-known knowledge network, they primarily capture syntagmatic relation. So syntagmatic relation arises from two words occurring together in a sentence. Okay. For example, paracetamol and momentum, they are unlikely to appear together in a sentence. It is very, very remote possibility. But paracetamol and fever are very likely to occur together in a sentence. So there is a strong syntagmatic relation between paracetamol and fever, and low syntagmatic relation between paracetamol and momentum. So let us remember this definition. Syntagmatic relation means relation arising out of a syntagma. Syntagma is any kind of syntactic environment, can be phrase, can be sentence, and so on. Whereas paradigmatic relation refers to the properties, inherent properties of words. For example, it is inherent property of cat to be an animal. So the word cat and animal are linked because of that property. This property is called hypernymy, hyponymy. Hypernymy, hyponymy. Cat, the class of cats is a subset of the class of animals. This is hypernymy, hyponymy. So now there are the other foundational points. Desire of some words in the sentence. This is called akanksha. I saw a boy with a long hair. The verb saw and the noun boy desire an object here. The verb saw desires an object, and the noun boy supplies that object desire. Appropriateness of some other words in the sentence to fulfill that desire. This is called yogyata. I saw the boy with a long hair. So with long hair can be appropriately connected to the boy and not to saw. So with long hair being connected to saw does not really make sense. Right? We do not see with hair. And in case the ambiguity is still present, then proximity is the next property which comes into play. That's called sannidhi. I saw the boy with a telescope. We know it is an ambiguous sentence, but proximity signal will disambiguate, saying that telescope is closer to boy in terms of word distance. Therefore, the boy has a telescope. So akanksha, yogyata, and sannidhi are foundational points recognized by Indian linguistics for disambiguation of words or phrases. So selectional preference is very similar to akanksha. There are words which demand arguments like verbs, prepositions, adjectives. Sometimes nouns also require other nouns or another part of speech word. And arguments are those which have the property to fulfill that demand. They must satisfy the selectional preference. For example, if we take give as the verb, then it has the desire for an agent. And that agent has a property. The agent must be animate. Only an animate entity can give something. What is given is the object. It is the direct object. So the one who receives the object or the beneficiary is called the indirect object. So I gave him the book. Here, him is the beneficiary, book is the object, and I is the agent. I gave him the book yesterday in the school. So yesterday in the school is not necessary grammatically. Without this also the sentence will be complete. But I gave him doesn't complete the sentence. Gave him the book, who gave the book, that is needed at least in English sentences. And I gave him, what did you give? Book. So this is the akanksha of the word gave, and it requires these objects. How does this help in WSD? So this kind of agent object, indirect object, direct object information help in disambiguation. But there is a chicken and egg situation here. Do we have to first disambiguate and then disambiguate the words and then disambiguate the relations? Or it should be the other way? Typically, both go together. Okay, you make some progress in one task, the other task also gets helped. Some progress in semantic role labeling that throws some light on words and disambiguation. The verb argument frame is very important. Just like we saw in give. Give is showing the argument frame of the verb. Agent, object direct, and object indirect are involved in this. So selection preference demands that there should be other words, and those words should have the property of meeting the selectional preference requirement. So if I say I am fond, then that doesn't complete the sentence. I have to say I am fond of what? So if I take the argument structure of fond, then we say that fond must be the argument one of a prepositional phrase. And that prepositional phrase has the structure of and NP. I am fond of cricket. I am fond of cakes and so on. And that NP should be somebody or something. I am fond of John. Similarly, we have seen the verb argument frame for give. Now we come to the parameters which have to be kept in mind for constructing lexical knowledge networks. Lexical knowledge networks fall in a spectrum of manual creation to automatic creation. So the domain for the lexical knowledge network. So is it a knowledge graph? Nowadays we call lexical knowledge networks as knowledge graphs. Is it a knowledge graph for food domain? Is it a knowledge graph in the medical domain? So we, for example, created a knowledge graph for different organs of the stomach. This was my PhD student, Kaveri Kale, who created knowledge graphs for 6 to 7 organs within the stomach: intestine, pancreas, stomach, within the abdomen area, sorry, stomach, liver, gallbladder, and so on. So the domain addressed by the structure, is it for law or medicine or sports and so on? The principle of construction. What are the principles that will get elaborated as we go ahead? Method of construction. Is it automatic, semi-automatic, manual? If it is automatic, does it make use of dependency parsing, which typically it has to? Representation, how will the knowledge graph be represented? It is typically represented in the form of tuples these days, entity 1 and relation entity 2. What is the quality of the database? The knowledge base which is created automatically requires manual inspection for quality. But if it is created manually with language experts, then they are of high quality typically. What is the application of this knowledge graph? Typically, many knowledge graphs are used for disambiguation or to reduce the corpora requirement for training machine learning models. Usability mechanisms for software applications and users. What is the API? What is the record structure? What are the user interfaces and size and coverage? So first, knowledge graph, which is to be discussed and which is very, very famous is WordNet. So let me give a demo here of the Indian language. Go to Google and search with Indo WordNet. Then it should take to the home page of Indo WordNet. Is the screen visible?
Yes, sir.
Okay. So it has all these languages captured in the knowledge graph: Hindi, English, Assamese, Bodo, Gujarati, Kannada, Kashmiri, Konkani, Malayalam, Manipuri, Marathi, Nepali, Sanskrit, Tamil, Telugu, Punjabi, Urdu, Odia. So let's maybe go by English first. Start navigation. Say house. So I learned that house has 12 senses. And the first sense is being shown. A dwelling that serves as the living quarter for one or more families. This is the most frequently occurring sense of house. So see the structure. It is first given an ID. This is 1901. The part of speech is noun. It has the synonym set, the set of other words with the same meaning. Now the gloss is an explanation for the word, for the sense that is being depicted, a dwelling that serves as living quarters for one or more families. An example sentence comes in, he has a house in Cape Cod. Gloss in Hindi, मनुष्यों का छाया हुआ स्थान जो दीवारों से घेरकर रहने के लिए बनाया जाता है. Okay, and then the gloss in English. So we can see equivalent scene set for other languages. So Hindi, we can see the Hindi scene set. The Hindi scene set is this: Ghar, Griha, Makan, Sadan, Shala, Alay, Dham, Niketan, Nilay. Ketan, Parn, Geha, Sarai, Ama, Nishadan, Avasat, Avasthan, Agar, Agar, Ayatan, Ashraydam. All these are synonyms with the sense of a dwelling where families live. And the ID is same, 1901. We can see for Bengali. For Bengali, the synonyms are shown here: Bari, Griha, Shadon, Aloy, Dham, Niketan, Nilay. And the gloss is same as Hindi. Then there are example sentences. এই বাড়িতে 5টা ঘর রয়েছে. Now, how are the synonyms arranged? Synonyms are arranged by the most frequent occurring coming first. We can see other languages also. There are Marathi speakers in the class. So this is the Marathi scene set and the gloss. Ghar, Griha, Sadan, Alay, Vasati, Sthan, Niketan, राहण्यासाठी बांधलेली जागा. माझे घर येथून फार लांब आहे. Then you can see for Assamese, very similar to Bengali. You can see for Konkani. Then if there are Tamil speakers, they can see the scene sets here, and so on. So scene set is the core of a wordnet. It is a set of words whose one sense has to be same. Okay, then the next important relation is hypernymy. So this is the English inset of house. Let's see the next sense of house. House can mean a theater. The word house should appear in the inset along with the synonyms. A building where theatrical performances or motion pictures can be presented. The house was full. Okay, the house was full here. It is in the sense of a theater or a movie hall. Now, what would be the hypernymy? So theater is a building or edifice, a structure that has a roof and walls and stands more or less permanently in one place. There was a 3-story building on the corner. So theater is a kind of building. Let's see hyponymy, which hyponymy is not found there. What are the different kinds of theater? Holonymy, meronymy, no. Meronymy should have been there. What are the parts of a theater? Okay, onto tree. Yeah. So it's a physical place. Theater is a physical place. Verb relation, noun relation, derived form. No. So many other entities don't apply to this. Let's take the next sense. This is also theater. House can also mean an aristocratic family line, the House of York. House can mean a family, a social unit living together. He moved his family to Virginia. An official assembly having legislative power. So a bicameral legislature has two houses, House of Lords, House of Commons in England. And we also have Lok Sabha, Rajya Sabha House. So let's see, hypernymy. Hypernymy means house is a kind of what? So it's a large indefinite number, battalion, large number, multitude, plurality, pack. House is a kind of multitude. Hyponymy, no hyponymy, holonymy, meronymy. Okay, so let's see if we can get the meronymy relation. Let's search for room. Room also has 5 senses, an area within a building enclosed by walls and floor and ceiling. Does room have a meronymy? Yeah, room has a meronymy. Meronymy means part of. So roof, for example, is a part of the room. Door is a part of the room. Wall, floor, flooring, these are parts of room. So do try to navigate in the WordNet. There are, of course, imperfections and so on. Some synths get repeated. We are identifying that some of the data is repeated. Sometimes the relation is missing. But there is a team which is working on WordNet. It was Hindi WordNet was created and released in 2006. And all other languages WordNets were linked by the year 2010. So this was the first major project for Indian languages involving all languages and their semantics, which is a complex task. Semantics is meanings of words. So notice that here words are documented such that their meanings are made unique. And the meanings are made unique through other synsets, the gloss, which is an explanation of the concept, and example sentence. Let's see the Hindi for room. Kamra, kaksh, ghar, koshtha, room, cell. So kamra is the most frequent word for room in Hindi. Next frequent is kaksh. Let's see for Marathi, which is the most frequent word for room. Kholi. Kaksh is second frequent, and then room comes here. Hypernymy, Thikan, jaga, sthal, sthan. So a room is a kind of thikan. Hyponymy, yeah. So a room can be there can be different kinds of room, like atithi kaksh, guest room. Guest room is a kind of room. Sayagriha is the bedroom, so it's a kind of room, and so on. So these have been created over several years by large teams spending a lot of money. And English WordNet came in 1992, European WordNet came in 1998, Indian language WordNets came in 2006 to 2010. And these are all high quality resources. You can also look at a very nice resource called BabelNet, which was created in Italy and links lots of European WordNets. There is also Euro WordNet. So those are important developments in NLP, and they have continued to be useful even for machine learning. So we'll continue this discussion on Sunday, and then give an overview of the course, and then finish it. So we'll finish the lecture